So just to put a finer point on the database evolution, we've already talked about the fact that databases in the original sense were just simply files, and then you accessed records in those files either directly to a location or sequentially from the beginning of the file. But that was the old way, and that's how things started using traditional file processing techniques. So each user would then define and implement the files that they need for a specific application. When the database approach came along, a single repository was able to maintain the data so that it's defined only one time and then it's accessed multiple times by multiple different places. A set of characteristics that describe the database approach is that it's self-describing. We've talked a couple of times about metadata, so that the database knows and understands the structure that's within it. It also insulates between programs and data, so there's a sense of data abstraction so that you don't understand how things are created on the underlying uh, operating system. There's no need. You only need to understand how that data is logically organized. So another thing is the database approach supports multiple views of the data. You can look at the data from different angles, and it allows an analysis that you may not have had in a file processing system. And then sharing data and multi-user transaction processing. So allowing multiple people to access the data at the same time, and then you're sharing a single location. So in other words, that single location is the truth as it comes to that data, and you can trust it from that standpoint. So I'm not going to talk extensively about some of these, but these are the different databases that have come about over the years. The first two, hierarchical and network databases, came into use in the 1970s. They're both mainframe based systems that organize data physically. Um, on the hierarchical side, it's in a tree structure so that you have a root node and then you're able to access from that root node. But on the network side, you have um, having a child node that may have more than one parent node, whereas a hierarchical database, it's a parent-child relationship where each child has a single parent. But the network database is quite similar to that. Relational databases were introduced in 1970, but the widespread use of relational databases was not until the 1980s. And it organizes things into a table format, like we're familiar with Microsoft Excel, and we understand how tables look with rows and columns and things like that. This is how the relational database model is organized. So the data is then connected across tables logically using foreign keys. So we don't have to now understand the structure of a file like we did with hierarchical or network databases. An object-oriented database peaked in the 1990s. Um, the data is organized as objects rather than specific tables, so it improves the representation of real-world things. So a single class defines an entity, a real-world thing that we want to store. But what tended to happen was the use of relational databases was so pervasive that we needed a way to combine those two ideas. So object relational databases arose in the 1990s because object oriented databases had limitations because of their deep integration with object oriented programming. So the object relational database allows features of both relational databases and object-oriented databases. And most of the database management systems that we see today are object relational. They have a way to use object-oriented design, but they are also very table oriented. The next thing to come about in the 2000s was a result of big data. So we had an increase in the amount of data that we were storing. We had an increase in the amount of things that we had access to. So we needed a fast way to store that data and then access it later for review. So data warehouses are a way to organize data into a star schema or a snowflake schema so that you can access a central idea and then have dimensions on the outsides of that uh, and access large volumes of data very, very quickly. A little bit later in the 2000s arose NoSQL databases and big data file storage systems. These kind of came along together so that a big data file system really, the Google file system was one of the earliest of this, and it allowed for large file storage. And then Hadoop is probably the most common today, and that grew from the Google file system. So NoSQL databases are also a reaction to big data in that a lot of the data that we're receiving today from different sources is organized in a way that is, well, the data is coming from all these different sources, so the data is different. So you need a way to quickly store the data into an unstructured or semi-structured manner. So NoSQL databases do not use tables. They use several different mechanisms, but the most common is a document storage system. So you're storing things as a particular document using binary JavaScript object notation, which is a language representation. We'll talk about that toward the end of the term in a little more detail.